Okay, we're recording. So I have a couple of things I want to talk about. I want to talk about sort of the role of the naming of resources and the mechanism that turns those names into accessing the resources, and how that relates to both concurrency and sharding. Because what sharding really is just another mechanism for gaining some concurrency. That's what it's there for. And if you understand how the how various technologies have sort of come to converge, then you can understand sort of better the requirements of the space and what things are likely to work and what things won't work, just by having a kind of a more zoomed out view of what's going on. So the technologies that I'm talking about are, of course, URLs and URIs in the World Wide Web. But maybe lesser known to the broad community, but more well known to programming language design and security folks, is object capabilities. And then, of course, I'm talking about the mobile process calculi that have really investigated these issues from a mathematical perspective. So all three of those technologies have converged on a very, very closely related set of ideas, and and so if you put them all together, you start to get a good solution. And when you have this kind of convergence, it's really important to pay attention. When you have a technological convergence, then it's important to pay attention because it's likely that you've got something of pretty high utility. Another example of this kind of thing is the comprehension. Right? So if you look at the notion of comprehension, comprehension showed up over 150 years ago with Cantor and set theory, right? So it's set theory, comprehension notation without the comprehension notation, I would argue that set theory would be not nearly as useful as it is, and would not have, possibly not have even enjoyed its role as the foundations of mathematics for as long as it enjoyed that role. But the set theory comprehension gave a language in which to write down and express a number of ideas. And then, of course, it showed up again in databases, relational databases. So the select from where statement is just another form of comprehension. And then in language design, whether you're talking about comprehensions in Python or do notation in Haskell or the for comprehension in Scala, all of these different pieces of all of these different sort of manifestations of the same idea illustrates its super high utility. So when you see the same thing kind of showing up like this again and again, or you see it, even better when you see technologies that are developed by relatively independent communities, converging on the same ideas again and again, then it's time to pay attention. So the point with respect to the three technologies I identified, right? So URLs, URIs, and the World Wide Web, and object capabilities, and mobile process calculi, is understanding the difference between the name of a thing and the thing. um, you know, in Latin, there's the de re, the thing unto itself, and de dicto, the name of the thing, or the words of the thing. And with computational entities, we're often forced to only use the names of things because a lot of computational entities are infinite, and we can't. It's hard to have direct access to certain aspects of things that are infinite. So the natural numbers we can handle because of their inner recursive structure. So we can talk about the natural numbers in terms of representations. You know, like n equals 1 plus n. So that's a representation of the natural numbers, but it's not the natural numbers per se. So in the same way, in the World Wide Web, we have this notion of a name for a resource, but not the resource itself. So that's the URI. In the World Wide Web, yes, I understand. The World Wide Web provides us this really nice abstraction, which is the URL or the URI, which has structure inside it. And the World Wide Web utilizes that structure to forward along the network to get to the resource. Right, so the URI reflects an abstract view of the network structure itself. So as you gobble up the path, you're also gobbling up steps in the network, roughly speaking. And there's a little bit more to it than that, but roughly speaking, that's the idea. So the path gives you a kind of a homomorphic view of the network. And that's good, right? Because it allows you to not have all of the resources located in one flat space, right? You can sprinkle them over a network, and then you can refer to them via paths in the network. Let me just stop there. I've said a whole bunch of stuff. Make sure that people are tracking what I'm saying.
It makes sense for me.
Okay.
And the URL can be also seen like the path. For example, when we access some object, accessing some fields is like a path.
That's correct. That's exactly right. And you're drawing the connection to object capabilities. That's exactly right. So, but object capabilities began to touch on another thing. So the URLs, at least as initially conceived, were mostly about resources that were stateless. So the initial conception of the World Wide Web was that you're going to retrieve documents. Now, eventually people realized that, you know, if we're gonna, there's super high utility in being able to access resources that, you know, have state, like, you know, your bank account or a traffic and airline ticket reservation system, things like that. So but the initial conception was stateless, and and there was a lot of work, and unfortunately it was incredibly ad hoc for the World Wide Web to incorporate entities that have state that you can mutate. And by the way, mutation, you know, despite its bad rap in functional settings, mutation is a highly compressed, highly efficient way to address the management of state and state change. As long as you know what you're doing, as long as you've got some kind of mechanism to support you, it's a fairly highly efficient way to manage state and state change. But object capabilities take it a step further, and they don't just talk about state, they also talk about security, right? So the idea is the management of sensitive resources depends upon which URIs or URLs or which monikers, I'll use the word moniker sometimes, generically, which moniker you have for the resource. One of the, if we can think about these monikers as providing paths to containers for resources and not just resources, then that begins to not only reconcile the notion of stateful and stateless entities, right? So if the path gets me, if a portion of the path gets me to a container for resources, then I might modify which resources the container holds. But likewise, if that path is, that container view gives us a notion of security, right? So if the container is like a room, then two agents can have a conversation in the clear, without cryptography, in a room if nobody else knows where that room is. So that's a lot of information. Let me check in and see if people are tracking what I'm saying.
When you say container, can this also means like a set of operations?
Yeah, by container, I mean, essentially, I'm meaning an abstract data type. Yeah. Okay, so that's, so the object capabilities sort of says, you never have the thing, you have the right to you have some capabilities to operate on something, right? So it's even more abstract. And then it turns out that the mobile process calculi give us a very nice mathematical framework in which to reason about all of it. So these intuitions and some technical guidance. So the technical guidance from the World Wide Web was, we're scattering these resources around the network, and so the names need to have path information about the network. So they have to have at least that much structure. And the object capabilities increase that view or enrich that view to say, and with this kind of information, we can reason about security, and what you gain access to are different operations or capacities of a stateful resource. And then the mobile process calculus say, yes, that's all great. That's all very important, and there's important operational intuitions. And here's an equational framework. Here's an axiomatic framework in which you can, a simple axiomatic framework, which allows you to formalize all of those intuitions, right? So that's one of the roles of the mobile process calculus. But the other thing that it does is it increases the sensitivity to concurrency. It says, and if you want these resources to be autonomous and able to execute concurrently, then here are some of the things that your mathematics has to support. And it gives us other things. So for example, it gives us an effective notion of equality of agents that can be resources and can utilize these resources. And that comes with all kinds of important aspects of substitutability, which is one of the most important things to get to software reuse. So those three technologies come together in this way, and they enrich each other to give a wider and more effective and deeper view of this idea of resources scattered around the network. So let me just check in and see if this is making sense.
Yes.
Okay, all right, good. So then the next, I'm gonna switch over to a different device so that I can add some.
And these resources can also be when we organize our code. We can say like these objects that represents our state, we want to have some control how they are accessed, and in that way we can split the operations and
yes,
in that way have control how state is changed.
That's correct. That's exactly right. Okay, so let me, I'm switching devices here. Hang on 1 second.
Okay, can you guys hear me?
Yes.
Okay, great. All right, so that was relatively seamless. Okay. So now the next step in this is to look a little bit more deeply at the concurrency. So if the path structure of the resource moniker or URI, it talks about its location in the network. There are other things that we could add to the resource moniker that would, and how to relate the resource moniker to the resource that would help with some of the concurrency and transactional semantics. So let's take a look at that. So the World Wide Web was not intended as a transactional internet, but we need the internet to be transactional, right? And that's why today, there's so much more than the original 1.0 HTTP spec, right? So there are cookies, which help with state management and session management and all that kind of stuff that crept into the protocol that weren't a part of the original conception. But a lot can be understood if we want to ask ourselves, when is it the case that Alice and Bob's transactions on a stateful resource have to be can run concurrently, and when they have to be sequentialized. So the relationships are depicted in this picture. I hope everyone can see that. Can everyone see that?
Yes.
Yes. Yes.
Okay, great. So you've got some agent that has an interest in a resource, wants to potentially modify the state of a resource, such as purchasing a ticket, withdrawing or depositing money into a bank account, or any of a number of actions that modify the state of a resource. the agent only has access to the resource mediated through a moniker. And so, for example, typing a URI or URL into a browser, and then the system turns that moniker into access to the resource. Now, in the case that the resources are separated from each other and the monikers are sufficiently separated from each other, and this is important because once we introduce this level of indirection, then there are additional ways that things might get tangled up. So we'll go through those in just a minute. But if the monikers, or the system that is sort of turning the monikers into resource actions, are separate and the resources are separate, then the picture makes it absolutely clear. They can proceed in parallel. So what are some of the different ways that they can get tangled up? Well, the most obvious one is even if they have two separate monikers and the system allows them to have concurrent access through the monikers, but the resource itself is actually the same, right? So Mr. Smith and Ordcut, or Ordcut and the man in the black fedora. So Ordcut, the man in the black fedora, are the same person, right? So that's the issue. We don't necessarily know that when we have a moniker what resource it refers to. What we have is potentially, if we take the view of the World Wide Web, what we have is a path to the resource, but there might be multiple paths to the resource, the same resource. Just like there can be the same name for different names for the same person, right? A person may have a nickname, that kind of thing. So that's one way that we can get tangled up, right? And in that way, we don't necessarily, have the advantage of, so that's a property that we would like to insist that names have, is that if they are sufficiently apart, then they shouldn't touch the same resource. Well, before I go on, let me just check in and see. So does that make sense? Is that clear?
I'm wondering if we're approaching this from the wrong side. I mean, basically, if you, let's say what you have on the target end, depending on what kind of an operation is being done, and depending on what resource, you should be defining the rules at the target level, not at the names and everything else in between. Meaning, suppose it's a balance, a bank balance or something that we're dealing with. So we should have some rules about how much concurrency is possible, or perhaps no concurrency is possible on a balance type of a thing. Likewise, if it is an update operation, as opposed to a read operation, it should have perhaps concurrency is limited in some way, shape, or form, and it may be that we don't allow concurrency. But isn't that what we should be doing on this end of the picture? To me, what is the right end of the picture rather than on the left end?
If you listen carefully to your own language, you've separated the thing from the operations on the thing. And that's so as soon as you've done that, you've said that there's an abstraction, there's an interface that you want to go through. And essentially these monikers represent a notion of interface. So that's, so it's still built into your own language. And all we're doing is, if we take that approach, then what you're doing is you're just putting another one of these round circles in front of this thing, and that will be then covered by this case.
Okay.
Right. So in this case, here's and notice something that's happened topologically. just for fun, right? So in this case, we can draw two rectangles around the transactions, and those rectangles are separate. They don't include the elements of the other. In this one, we can't do that, right? Because of the way the paths to the target line up. There's no way we can draw two separate rectangles. So they're not separable in that sense. And likewise, if the tangle happens this way, they're not separable. Right? There's only one rectangle that you know, can be sort of drawn without torture or tearing to the graph or the rectangle. And then there's another situation that is effectively like this. And so if you think about what's going on with Ethereum, what's wrong with Ethereum is, regardless of how much separation there is in resources on the back end, you have to go through a single point here, right? That's the sequential virtual machine. So I should articulate this picture a little bit to get there. So let me go back here, get rid of this. So in this situation, right, so the Ethereum case, it is quite possible that the resources are separable. And Ethereum is providing the choke point to get, so you have to go through, so now the URI that you've got is an Ethereum address. And so the node in the network that has to dereference the address to the resource is sequential. And so all the concurrent requests come in through here, even if the resources are being accessed, are independent, right? So the essential difference between Ethereum and Archain is to recognize that if you're careful about the resource and the system that dereferences the moniker to get the resource, then you can recover this picture here. Is that making sense?
Yeah.
Yes. Mm-hmm.
All right. So that's kind of that's the first step. Now sharding, what sharding does is it sort of turns up the magnifying view on this thing, because what the blockchain does, as opposed to what the internet does, is it takes this node and it replicates it. Right. So the World Wide Web doesn't have built into it an idea that the nodes may be doing the same job, and because they're doing the same job, they're being replicated because any one of them might be faulty or fail. But if we have a bunch of them all doing the same job, then it's more likely that the job gets done. And that's what the blockchain is providing for us. The blockchain is providing the replication of these circles. And of course, since they're replicated, they have to be kept in sync. So I have more pictures that I want to draw. This is still work in progress. for this article that I'm writing. But essentially, the idea is that you turn this one circle into a circle that contains a lot of circles, right? And that's the blockchain. And all of those circles are effectively connected to every other one. Now, they're not directly connected. They may only be connected to a handful, and that's all they need. But ultimately, the logical picture is of a complete graph. So that's the inside of one shard, and that one shard is providing a way to consistently dereference from a moniker to a resource. So I haven't yet drawn the picture that helps that understanding, but hopefully the English is clear enough that makes sense. So essentially what we're doing is we're taking this one bubble and we're turning it into a bubble of bubbles. And from the perspective of the topology, the logical topology, all of those bubbles are every bubble is connected to every other bubble. So those bubbles are part of a complete graph. And that is necessary because what we're doing is we're providing a kind of fault tolerance, right? So you can hit any one of them and it has a view of all the other ones, right? So in the case of our chain, for example, if you hit any one validator, it should eventually, for finalized blocks, be able to be in agreement with all the others that have finalized that block. So each node has a consistent view of the finalized blocks. Is that making sense? Each little circle inside the big circle. Is that making sense?
Yeah.
I'm not really sure. You mentioned that each node has all nodes has a consistent view on the finalized block, but different nodes can have different finalized blocks depending on block propagation.
Yes, of course, but to simplify the discussion, let's say in the limit, if no new blocks were being published, eventually they'd all come to the same view about the finalized blocks.
I see. Okay.
Yeah. So that's the idea.
Mm-hmm. Just one. I noticed that when you were talking about blockchains, you mentioned that this is a replicated state machine, but it also offers the Byzantine fault tolerance, not just about
the way
failing.
But the way what the Byzantine fault tolerance is doing, the fault tolerance there is to make sure that they all have a consistent view. That's what it's there for. Whatever your consensus mechanism is, the consensus mechanism is to get them to come to an agreement about the state of the resources that they are able to dereference names to.
Mm-hmm.
That's the point of it.
And one more question. You're talking here about a shard. So where is the place of the particular node here? Because I'm not sure I understand what's the difference from one single node, which is the Erlang virtual machine running on the RSpace, on the state, and the shard that are a bunch of nodes interconnected. From the math standpoint, where is this difference?
So that's exactly what I was. I'm glad you asked that question. That helps me know how to tell the story better.
Cool.
Okay, so essentially what I am saying, let me move these over a little bit, draw the picture better. get rid of these for the purposes of this discussion. Move this down. All right. Then what I'm saying is that there are a bunch of these inside. So from Alice's point of view, Alice really doesn't care about the individual identity of the nodes in the shard. Alice just cares about the shard, and that so Alice has a URI, and the URI only sees as much resolution as the shard, and then inside that shard are specific nodes, and the reason they're there is so that if any one of them goes down, the rest of them can keep the job going in terms of being able to dereference to a resource and update its state. That's the basic idea. Does that answer your question?
Yes. Yeah, I believe, I'm not sure that I well formed my question, and I'm not sure that what exactly I meant to ask. But I've seen these kind of there is a resource, and there is a entry point for resource, which is kind of providing some object capabilities, so user can access this resource through the gateway.
Yes, that's right. That's exactly right.
And
go ahead.
And I was wondering, so from the shard standpoint, the picture is, so from the user standpoint, it doesn't matter if it's a shard or if it's a node, because shard can be just a single node. So from that standpoint, if you're talking about a node or just about a shard, it doesn't matter, because it will be the same logic.
That's correct. That's exactly right. So from the user's standpoint, the user has a moniker, right? A URL, URI, or something else, an address on a blockchain, right? So from their point of view, they have a thing that they can exchange with the system, in inverted commas, to get to the resource, right?
Yes.
And the thing doesn't have, the moniker that they have doesn't have enough resolution in it and by design does not have enough resolution in it to say that this part of the network is actually made of lots of little copies of itself. Right. So that's and the user doesn't care. The user cares about, I know if I use this name, I can get to this resource, right? And the thing that's converting names into resources can do so in this clever way, this clever fault-tolerant way. But from Alice's point of view or Bob's point of view, she doesn't care about that part, right? That's plumbing, right? That's under the hood. She doesn't want to know about that.
Yeah. Yes, I guess it's more clear for me what I was interested in. So basically, when you are talking about shard and the sharding, I was imagining that we're talking like a bunch of nodes, but we're actually talking about the same rolling state machine. And shard is not like a number of nodes. It's just a representation inside the state machine.
Oh, let's pick that up later.
Sure.
There's a lot to unpack in that, but we won't get where I'm trying to go without.
Sure.
But these are very, very useful questions. So the next point of view is to just iterate. So what the approach that Archain takes is simply to remember the point about the network. And so we can, since the path in the moniker to here doesn't resolve to any one individual, then out from here, you can put more nodes, not just resources. These don't have to end in the same way that, so the view of the World Wide Web is something like this. Let me change this shape. Ah, got it. I have to go to here and turn this back into that. Right. So that's so we can keep iterating, and in fact, these things can also be replicated internally, right? And then eventually we'll have a path. Let me see if I can get this drawn while I'm talking. Come on. There we go. Okay, that's fill. Well, it's a little too small. Let me make it slightly bigger. There we go. Sorry. All right, so eventually we'll have a path out to a thing that is a resource.
Yeah, makes sense.
Right? Where is the, my poor brain is not seeing it. There it is. Okay, right? And each one of these can either be individual nodes or they can be these replicated things like a blockchain. And the point of that, of course, is to be able to have networks of replicated nodes that essentially perform what the World Wide Web was originally designed to perform, right? Which is to take Bob or Alice's moniker and give her access to a resource, right? That's the idea. And if you're careful and you do your analysis right, then there's lots of information about the that remains in this logical view of the network. So in particular, if you can sketch a path, now let me go back here. I think it's here, yeah. Oops. I can just shrink it down a little bit more. There we go. So if you're careful, then you can find these paths, right? So if Bob's request comes in and you can trace the path along the network in the way that I've shown, then you can find these separable rectangles. Does that make sense? And once you see that you have this kind of separation, then you can have concurrency. And if ever you get into a situation like this one, or that one, and where you see that you can't draw the two separate rectangles, then you know that you have to sequentialize. And the nice thing is, as I've tried to suggest with this picture and with the rest of them, is that the monikers will have a huge percentage of the information about the path to the resource. So you can do a lot of the analysis as long as you insist that your monikers have a certain property, i.e. avoiding this situation. As long as your monikers avoid this situation, it's only a generalized form of this situation, right? You don't have to have uniqueness of names. You just have to have a kind of separability property, right? So much of woolly internet thinking and woolly philosophical thinking asks for unique names for all things, and that's not a requirement. Not everything on the network has to have a unique name. And in particular, when we're talking about networks like this, we don't really care about these names from the point of view, from Alice's point of view or Bob's point of view. They might have unique names, but we don't care, right? The clients do not care, at least for the purposes of accessing the resources. They might care for other reasons, but for the purpose of accessing the resources, they don't care. So uniqueness of names is not important, but separability is important. And we can use these separation properties to find these rectangles. And when you have the separation, then you can run concurrently. And when you don't have the separation, so this case, then you must sequentialize. And that's the role that all of these things play. They're all coming into agreement about the sequential order in the case that they can't be separated.
Can I
Go
ask
ahead.
a question?
Yes.
So on one picture, you have two resources. When you can separate two transactions with two rectangles, each request end up with a different resource.
Mm-hmm.
And if they need a single resource, it still be non-divisible, single transaction that will be conflicting. Because
Right.
here you have two different resources. On the previous slide you have, this one. Even if there are two monikers that are pointed on the same resource, you cannot divide them within two rectangles.
That's correct. That's exactly right. So the role of this entity that I've got highlighted here is to make a sequence. So even though these two requests are coming in at the same time, this resource is going to say, we're selecting Alice first before Bob, or we're selecting Bob before Alice.
I see.
Yeah. And so what this does is, go ahead.
So isn't this just falls down to if there are two separate resources, they can be proceed in parallel? Why do we need to separate the monikers? So if you have two different resources, we always can draw two rectangles.
If we can, yes, but the problem is that we never just have the resources. Increasingly, as the internet becomes more and more complex, we never have the resources. We only ever have a name for it, right? And that's why I mentioned at the beginning of the conversation before I used the pictures, there are some things for which direct access is very, very hard for human beings, right? So the natural numbers are, it's difficult for us to get our hands around the extension of the natural numbers, right? So the extension of the natural numbers is the infinite set of all the numbers, right? So we have to have a moniker which allows us to address the natural numbers. Like if I were to try to tell you the natural numbers by saying, well, 0 is in it, and 1 is in it, and 2 is in it, I'd never finish that statement. But instead I say the natural numbers, right? And that takes a finite time to communicate over this Zoom call. Does that make sense?
Yes.
Okay. So we and in particular, because we're building networks of things, and we're sprinkling the resources around the networks, right? We never have a direct access to the resource. We have a path from where we are to the resource. So it's always a moniker.
And this path can intersect as well.
That's correct. And that's why it's important to disambiguate between the monikers and the resources.
I see.
Yeah.
Thank you.
Sure. No, thank you. These are great questions. These are great questions. So any other questions? So I'm, I just wanted to sort of give people a taste of what I'm writing for the article, which is a response to the Twitter thread that someone had posted about that they felt that sharding was not a good thing, and I want to point out that sharding, at least in the sense that I'm talking about, is not only good, it's natural, and it's been discovered again and again, but in particular, we use it every day in the World Wide Web. And if the World Wide Web were transactionally aware, then it would, serve the functions that we want it to serve. And there's sort of some basic properties that you have to maintain in order for the World Wide Web to become transactionally aware. And that's essentially, blockchain provides a piece of it, object capabilities provide a piece of it, the World Wide Web, the URI provides a piece of it, and then the mobile process algebras provide the conceptual framework in which to stitch it all together. So any other questions about this?
I have a question about URI. Can we say that basically we have a rolling for this purpose, like the whole language, which tell us exactly the URIs?
Yes, the sort of the point of the row calculus was to say, when you finish putting all the requirements onto the monikers, they look like programs. Right. And that's a long I've tried to argue that from first principles, right? So what I tried to do is to avoid all of the political fighting and all of the other kind of strange fighting and conflicts you might get in rolling out that idea to the wider community, and simply saying, look, if you want your account of computation to be fundamental and not import another account of computation in terms of the monikers, then you don't have a lot of wiggle room. The only place you can look is the programming language itself. And so that's what gives you the notion of moniker, and voila, monikers are programs. So that's the argument, but there are lots of different ways to argue this, and essentially one of the things that I've done, which you pointed out, is to instead of going, that was kind of the lazy route, the shortcut. So today's discussion was taking the long way around, and talking about it from that angle. Like if you want to address all the requirements of this particular marketplace, of this particular domain, then by the time you've addressed them all, then the monikers are programs.
And this is why you were talking about derivative of a type, because you wanted to have a type that describes this path, so we can automatically detect conflicts or not conflicts. And
there's a relationship, but the derivative idea is more general. So with the derivative notion, what I've tried to say is that if we have a type which represents a reasonable notion of container, if I take the derivative, I get the container with a hole knocked in it, and then if I have a pair, which is the type of the container with a hole knocked in it, and a sub-container which will fill that hole, which will plug into that hole, then the container with the hole and the sub-container together forms a notion of location. So it's very general notion of location. Yeah. So that's at a higher level than Rolang, right, or row calculus. In row calculus, I have a specific solution, which is to reflectively close over the programming language at hand, right? With the derivative idea, it's not reflexive closure. It's a generalization of the mathematical technique that was used to find the real numbers from the rational numbers, right? Which is to create a splitting, right? So there's what came before, that's the container, and what comes after, that's the sub-container that we plug into the hole, right? So that's a generalization of this idea. Whether you use Conway games and the notion of splitting that way, or you use Dedekind cuts and the notion of splitting that way, it's a generalization of that idea of splitting, what comes before and what comes after, and the location is like defined by, you know, those two pieces of information. And now you can use that for lots of purposes, not just locating resources on a network. In particular, you know, my argument is that if you wanted to, if you wanted to come up with a quantized notion of gravity, I'll just say it, then that technique is extremely general, and it comes with a derivative, right? So you get a notion of derivative directly connected to a notion of location, and that will give you that gives you a way to start talking about Einstein's intuitions in a quantized setting. But that takes us far afield from what we're talking about here. Okay, it's 1 minute to. I wanted to talk about something else, but this was enough. So thank you so much for your time and attention. And I'll see some of you on Dev Stand Up in a minute.
Thanks.
Thank you.
Thank you. Bye-bye.